Welcome, everyone. I'm Andy Murray, the Executive Director of the Major Projects Association, and I'm your host for this webinar, or DJ, I guess, to get the conversations going. We've run several of these Meet the Author sessions, and I'm pleased to say we've actually got sort of 3 for the value of 1 today. So rather than just Meet the Author, we've got actually a Meet the Authors, because the book that we're going to look at was a joint effort between 3 authors, and I'm pleased to say all 3 of them are joining this session. It's on a book that I think some of you may have seen some of the discussions already on LinkedIn and other social platforms, on a book called How to Measure Anything in Project Management, and it follows up some books on how to measure anything in business. I think was the first book, if I'm right, Douglas. If not, please do correct me. But people that have heard me present on the topic of data analytics may recall, an expression that I've used from time to time, which is managing a project without data isn't project management, it's just winging it. Because what it actually means is that we're just doing everything through intuition and without making informed decisions. But I suspect by the end of this webinar, I'm going to be corrected. And my strapline now should be, rather than managing a project without data, it perhaps should be managing a project without measures, is winging it. So, but we'll explore that as we go through. I've done too much already by way of introductions and talking. So you haven't come along to listen to me today. You've come to meet the authors. So if we could just have a quick introduction from each of the authors, a bit about who you are, your interest in how to measure anything and in projects, that would be great. And then we'll get the conversation going. So Andreas, Douglas, Alex, welcome. Which of you would like to go first? So Andreas, you're top of my screen. How about again, you've come first in the spotlight. So please say hello, introduce yourself.
Very happy to. Thank you for that kind introduction. So I'm Andreas Leed. I'm the head of data science at Oxford Global Projects, and I'm a PhD fellow at Aarhus University. And obviously this book has been a joint effort. We originally signed the contract for I think 9 months to complete the book, and it took us almost 2.5 years. So in terms of our own project management, I have to say there's now some new data on writing books for us.
Yeah, but I think there's probably quite a bit of reference class data out there on writing books, but anyway.
There is, and I think that's pretty typical actually. But it allowed us to go into additional topics, which we'll talk about today. So that was pretty cool. Doug, do you want to go next?
Yeah, sure. I'm Doug Hubbard, and Andy, you were very close on my first book. It was How to Measure Anything, really full stop. But the tagline was finding the value of intangibles in business, and I put intangibles in quotes. So because if you really care about something, it has to have detectable consequences. So that's my first book. This was the 5th book I worked on. It's the 2nd book I collaborated with other authors on. Actually, in terms of project management, I got to tell, I think I've told Andres and Alex this before, but when we signed the contract for 9 months, I really had no intention of following that. The publishers have their own timelines and we have ours. And this was well within our reference class for previous books, at least my previous books. It's well within my reference class. So 9 months, sure, I'll do that for 9 months. But yeah, we took as long as we needed to write the book. And if we would have finished it in 9 months, we wouldn't have said nearly as much about AI as we ended up saying. So things change fast, and we are able to include a little bit more. In fact, we talk about problems like this in the book a little bit because it's called technology regret. It's committing too soon to a technology while things are changing very quickly. So that actually has an impact on a lot of projects. So I've been in quantitative management consulting for about 37 years. I started at Coopers & Lybrand. In the past 27 years, I've had my own business, Hubbard Decision Research, and there's just 8 of us. I have 5 quantitative analysts other than my wife and myself, and our very useful, flexible executive assistant. But the 5 quant analysts, which Alex and Andreas have got a chance to meet, we get to work on a lot of different kinds of problems. And I decided I'd finally start to work on project management when I found the right co-authors, and lo and behold, I did. So, Alex, go ahead.
Sure, I can round us off or up. So I'm Alex Budzier. I'm part of the University of Oxford here at the Said Business School in our research group that looks at major projects, major programs, and also one of the co-founders of Oxford Global Projects, where we work with projects in real life. And the real interesting thing was Doug didn't mention was when I first learned about his work when a book came out that was called Why Risk Management is Broken and How to Fix It. And that had been on the reading list here in Oxford in our MSc, in our Master of Science for Major Program Management since the beginning, since 2009. And because it's such a interesting book and a good provocation to think about it. And so that was my first exposure to this line of thinking of, how can we make better decisions under uncertainty and get risks. Back then it was about risk management and being a bit more proactive in that, but also analytically a bit more rigorous. And when the How to Measure Anything came out, particularly around the intangibles, there seemed to be like a really good idea to start asking these kind of questions, because the other thing that I observed is as well that in many projects where we get involved, there's a lot of questions, and people always say, "Oh, we can't really measure that." Right? So we kind of, now on projects, we need to consider social value, or we need to make trade-offs between environmental impacts of a project and project cost or project timelines. And those are always, very strange circular discussions. Projects often get stuck in these analyses, and you can't really move forward because, social value is something that's really hard to grasp. And so when we started on this book, it was all about how can we improve that decision making on projects, particularly around some of those criteria that not as easy to sum up, like, for instance, project coster. Andy, you're on mute.
Yeah, sorry about that. I think I was muted. So anyway, so thanks for that great set of introductions, and just a couple of reflections. So Andreas, I'm disappointed that you introduced yourself as head of data science. I'm sure you must be the data science lead. So Oxford Global Projects has missed out on a name pun then. And Douglas, so I was interested in the 9 months bit, because often we talk about major projects sometimes have this charade, as I've heard it described as, of the commissioners and the deliverers going through how long something's going to take, and both sides being complicit in that whatever number's offered is not the number that either side is working to. So it's great to hear that that's not unique to the world of projects, but exists in publishing too. Alex, you've really nicely set us up for my first question, really, but perhaps we can have a sort of a 3-way thought on it, which is why write this book and why now? I would like to lead on.
I was just looking at this. I was just saying as well, now you know my story, why I think we wrote it. But Doug, do you have you probably have a different vantage point.
Oh, well, actually, all of my book titles that I've ever written were all based on analytics. So How to Measure Anything, I chose that because I did analysis of book titles and which kinds of book titles tended to outperform others. But all of my books have always been about decision science. I tell people jokingly that I put them under different titles to trick people into buying books about decision science, and they don't know that they're buying books about decision science. But How to Measure Anything and The Failure of Risk Management and all of my other books are about decision science. So I did this analysis a while back when I decided to do a bunch of spin-off books on how to measure anything. And the two at the very top, which were a tie, were How to Measure Anything in Cybersecurity Risk and How to Measure Anything in Project Management. And I thought, okay, well, I'm just going to try to find the right co-authors. I looked for co-authors for How to Measure Anything in Project Management. I did not know Andreas and Alex back then, but I did know a very enthusiastic and ready to work Chief Information Security Officer who wanted to write How to Measure Anything in Cybersecurity Risk with me. And so that was Richard Searson. And so we worked on that. I wrote a couple of additional editions of my previous books. And then one day, Andreas and another person from Oxford Global Projects called me up as part of a survey. And I forget exactly, Andreas, what the survey was about, but they were telling me about what they're doing, and they told me about Oxford Global Projects. And I said, you know, actually, I've kind of been looking for co-authors on this other book idea that was one of the top two. It tied with cybersecurity risk. And then I looked into it and I thought, well, gee, I don't think I could do better than Oxford Global Projects. I think I'm going to have to talk these guys into being a co-author or something. And it turned out that they were pretty interested in it. So that I was lucky in that sense. So that's how it started, I think.
Excellent. So it could be the serendipity.
I can add a bit more context. So we were actually doing writing an article we were getting paid for about cost-benefit analysis. And so we thought that Doug's input on what type of externality should be included in cost-benefit analysis would be really useful. So that was the first kind of meet and how we came together. But I think in the book, we spend a bit of time kind of justifying why do we talk about projects to begin with. And so we did some research. Alex has done some academic research looking into, you know, how much of the world economy, or how many of the hours we work in our economies actually go into projects or are in the form of projects. And it's about, depending on how you quantify the method, it's about between 10 and 40% of all the work that we produce in our economies are in the shape of projects. And when we look at all the project data we have access to, which is about 22,000 projects now, completed projects don't tend to perform very well. And that's even when we measure projects on the more tangible stuff like cost and schedule that projects they really try to manage to. The more limited data we have on benefit achievement is actually also shows the same kind of picture, that projects they don't tend to meet the expectations in terms of benefits. And so here we saw an opportunity on how can we actually, there's so many claims out in the field of project management, lots of single case studies that are generalized to the population, or lots of certifications and methodologies that promise better outcomes. So this book, we actually set out to figure out, you know, what are the methods that we can actually see that works, where there's any evidence for them improving outcomes for projects, and what are the methods that definitely don't help, so that we could, our hope was that we could actually try to filter all that noise and find the good stuff and present that in the book. So that's the outset. I now use, I'm teaching a course on cost-benefit analysis at the moment at the university. I'm actually using a lot of content from the book. So my students got access to some of the book chapters a bit earlier than everyone else. Yeah.
Brilliant. Yeah, and I can see that, Andreas, because anyone who's worked in sort of benefits management, benefits analysis, in fact, if anyone on this webinar, you probably just want to go over your last benefits case or business case where they're in there, and I bet a high proportion of them are in the intangibles space, and then therefore, what is the method and approach you're going to use to measure those? So I can see where that research led you to Doug. So the book, as with all good books, it kicks off with a definition. And the definition, if I just pull it up on my phone, is something around reduction of uncertainty through observation. So Doug, you've lured me into the world of decision science. So can you sort of explain more?
Oh, sure. Well, really for about 100 years now, in the empirical sciences, measurement did not mean an exact number. It means exactly what you said, quantitatively expressed reduction in uncertainty based on observation. Not necessarily, probably not usually, or very rarely ever does it mean an exact number. So when someone says we can't measure that because we can't put an exact number on it, they're misunderstanding the definition, the practical definition of measurement. And that definition that I'm proposing is the most practical for decision making. You're making slightly better bets. There's a value to making a slightly better bet, especially when the bets are highly uncertain and highly consequential. A little bit of analysis can have a high ROI. In fact, I make this point quite often in all my books, but your single most important decision in business, government, public life, personal life is how to make decisions. That's your most important decision ever. And so we have to kind of figure out that decision, right? So that's the beginning of the definition of measurement itself, is we have to think in practical terms. We make some observations, do some trivial math, and then we have a little bit less uncertainty than we did before. Sometimes a lot less uncertainty. People are routinely surprised by how much uncertainty reduction they get from the first few observations.
Yeah, and picking up on that, there was something in the early chapters of the book around the rule of five, and I found that really interesting in terms of, you say, the insights you can gain just out of just a small number of observations. So explain to us what the rule of five is.
Yeah, well, you can show mathematically, and this actually is pretty fundamental. It's axiomatic. But if you randomly sample 5 of any population of continuous values, maybe it's a database of people's medical expenses. Maybe it's a database of ages or heights of, third graders or something like this. You take any database of some continuous value, randomly sample 5 of it, and you've previously in advance computed the median of the entire population. Well, every time that you compute, that you randomly sample this sample of 5, you check to see if the median is between the upper and lower values of that random sample of 5. And the math will show that there is a 93.75% chance that the median of an entire population, doesn't matter if it's 10,000, a million, 10 billion, or 10 trillion, if you randomly sample from the entire population, there's a 93.75% chance that the median of that entire population is between the smallest and largest of that random sample of 5. Now, this surprises people. It is a consequence, a necessary consequence of basic probability theory. But I think a lot of people have these intuitions, or maybe they misremember some stats courses from college. And I think Andreas has been teaching some version of stats, and I've got two on my team that have been teaching stats at the undergraduate and graduate level for quite a while. And yeah, people have all these misconceptions. They remember things like statistically significant sample size. There is no such thing, by the way. You should all know that. There's no such thing as a statistically significant sample size. There's something called statistical significance, and there's obviously sample size, but there's no universal number where if you're one short of it, you can't make an inference. It's not how the math works at all. Technically, how the math actually works is every single observation, starting with the first one, moves the needle a little bit. In fact, the more uncertainty you have at the beginning, the bigger uncertainty reduction you get from your first observations. In other words, if you have lots of uncertainty, just a few observations will greatly reduce your uncertainty. It's later on when you have lots of certainty, very little remaining uncertainty, that it's very expensive to further reduce uncertainty, right? That's the difference between a cloud chamber that you could set up in a high school science course versus, CERN. It's very expensive to reduce that last little bit of uncertainty. So the way the math actually works is, and I use this phrase a lot, if you know almost nothing, almost anything will tell you something.
Mm-hmm.
That's the way the math actually works.
And the key thing, if I get my maths right here, Doug, that you use when you're describing that 97.3%, the 5 or the upper and lower, the median sits within the upper and lower of those 5, is that it's a sample. So, for example, I couldn't take the last 5 results of my Premier League team that I support and assume that the median points per game sits within the upper and lower of the points they've achieved over the last 5. That's not a random sample, is it? And it's not the entire
Right. Well,
population.
you can make an inference of the population you sampled from randomly. If you only sampled from the population of this last year's matches, well, that's the population that you're estimating the median for. So if you randomly sample from a larger population, that you get to make an inference about that larger population.
And there's also one other thing, right? So this is sort of the more uncertainty there is, the greater is the value of kind of measuring stuff, observation, right? So if, and yeah, I assume it was football or soccer you were talking about, right? And we know that kind of like scores are relatively low, right? Sort of often it's 0, 1 or 2, you know, so it's not like other sports like American basketball or, you know, sort of how you get like lots and lots of points. So the range of uncertainty, of course, is much greater because there's a greater range typically of how many points you score. So, and this is the other interesting thing, right? So then these kind of methods of inferences and statistics and predictability, right, work a lot better in games that just generate more data.
Yeah. Thanks for that clarification. So, and I guess that's where, linking it to the world of projects, we have that greater range and therefore that greater degree of uncertainty. Now, we've been discussing sort of various sort of mathematical terms, you know, in the past few minutes. So, do we all need to be maths geniuses to apply the sort of ideas and the concepts in your book?
No. And I think that's probably one of the things, if you look over the last couple of years, where AI has come leaps and bounds, right? So, you know, sort of the inbuilt ability to reason, write you little bits of code, explain how to do this in Excel, you know, is so much greater than it was just about, you know, just before we start writing the book. That's really exciting. I remember while we were writing the book, Doug got really excited that Excel has now this link where you can plug it into AI and start, you know, some asking questions and doing fancy math around distributions and suggesting things and so on, right? And now that we finished the book, right, whether you work in Google Sheets or Excel or so on, it has become a standard feature. So I think that kind of like, you know, what do we always say is, you know, you need to know kind of what you need to do or what you want to achieve and what would be the right thing. And our tools have now become so brilliant, you know, you can do this all in natural language, talking to a machine rather than learning how to code.
I think another point is that everything we talk about in the book, all these decision theory concepts, all the maths, actually isn't really that complicated. And we made the point to produce Excel spreadsheets that go together with the book. So everything we talk about, from Monte Carlo simulations to kind of machine learning type tools, we produce spreadsheets for. So you can go on the book's website and see you can actually do this without knowing Python or R. I think there's also another point to take away from, we talk a lot about this is how the maths works out, but there's lots of principles you can kind of distill from that. So for example, this idea that where there's the greatest uncertainty, you need the fewest observations to reduce that more. You can apply that pretty directly in your project. So typically projects have greater uncertainty around, you know, the long-term operations or maintenance of an asset that's built, or it can be around benefits. And so oftentimes with this principle, you should go out and measure those things. Whereas if you want to reduce the uncertainty on like the capital cost of a project, typically that is really, really expensive, and you might need to do a whole bunch of detailed engineering to reduce that further because you've been pretty robust about building that up. So this idea around thinking about what's more uncertain and what influences the business cases, and then actually going out and finding some empirical data, even just a few observations, can be really helpful.
Yeah, and that's the section in the book, isn't there, about the cost of measuring and the value of measuring, and that trade-off as to where it's best applied and where perhaps you don't need to apply it in the same level of rigor. There's some other things in the book I really like. There's a concept called analysis placebo. So Doug, tell us a bit more about this analysis placebo.
Well, it's a term I came up with to group together several different studies from completely different fields. Different studies in different fields that are far apart enough that they don't cite each other even. They're in completely different types of journals, different fields of knowledge. But in each of these studies, they were looking at how people would adopt methods that seem structured and formal. So apparently structured formal methods to improve estimates and forecasts of outcomes. And they would observe people's initial intuitions, their use of these structured formal methods, and then they would track their performance over time. And this was applied to estimating the outcomes of sporting events, horse races, the performance of investment portfolios, the duration of projects, and even the guilt of criminal suspects. These are all the different fields, and there's more in this space. But apparently what all these different researchers found that didn't know about each other, they all found that if you adopt a method that seems structured and formal, your confidence about your estimates and performance inevitably goes up, even when your performance gets worse. So, in medicine, a placebo is actually often a positive thing, because you have to beat the placebo with the drug that you're testing, right? So if you take a placebo in a drug trial for reducing blood pressure, your blood pressure might actually go down taking the placebo because you believe you're being treated. But this is worse than that kind of placebo because there's no benefit other than the confidence going up. And while your measured performance gets worse. So we have this inclination to believe that if I'm adopting a method that's structured and formal, it should improve my judgments. Therefore, it does. And this does not follow. This is not what we see in the data. So I'm trying to put people on the, I'm trying to warn them in advance about the existence of a placebo effect in analysis. Yes, people feel better about some of the things that they're applying, but how have you actually been tracking performance over time in large clinical trials like these studies have done? Otherwise, you wouldn't know if it's actually better or not. We're just kind of hoping that it's better.
To give you an example, right, there is a researcher called Magne Jørgensen. He works at the Simula Research Lab at the University of Norway in Oslo. And he did a lot of things and research on software development and those kind of tasks. And in one of those experiments, he did a fascinating thing. He had sort of 3 experimental groups. And one, he was asking sort of a standard software development task and was asking the developers, how long will that take? His second group, and he asked them, okay, how long will it take and what are the 3 risks that might delay the completion of this task? And then he had a third group, and that third group, I think he asked them to list 12 risks. And the interesting thing is that so the ones that thought more about the risk, particularly the 12 risk group, that went more into detail of their thinking about this, just guess or estimate how long this will take you, they became more optimistic, so they underestimated the true duration of the task. So they were more inaccurate in their forecast, and at the same time they were way more confident in their forecast than any of the other groups. So particularly the group that was just asked to give like just one estimate without thinking about risks at all. They were actually the least, they were the least confident, but also the most accurate group in that estimation task. So it's kind of that thing, right? In projects we always think accuracy and better data comes from a lot more granularity and breaking things down, and yeah, it is a placebo.
Well, we've had a lot of pharmaceutical clients over the years, and when they test a new drug, they have to do a placebo-controlled trial, or at least some other standard of practice that they're testing against. And when you've heard people refer to methods in project management as best practices. How did they determine that exactly. Did they run a large clinical trial? Probably not. They didn't. It's usually a bunch of people sitting around in a room, maybe with or without windows, and they decide, like a group, a consensus, that some way of doing things is a good idea. They didn't really test it in a large clinical trial. And so things like the analysis placebo and this, our skepticism about experience, this is really important too. A decision scientist I like to quote, Paul Schumacher, says, experience is inevitable, learning is not. In order to convert experience into learning, we need feedback. And that feedback has to be consistent, immediate, and unambiguous. Now, if you're hoping to learn from a business case on an infrastructure project, how long do you have to wait for feedback on your 10-year out benefits estimation, right? So it's not, by its nature, it's not immediate feedback. And it may not be very unambiguous. Who's measuring the benefits exactly? Did anyone even measure it to begin with, even if you did wait 10 years? So I think a lot of mega project management, for example, just doesn't live in the world where they can count on their feedback to inform their estimates. What we need to do is cast a wider net, look at larger sets of heterogeneous kinds of projects and interpolate. That's exactly how my life insurance company computes my life insurance premium. I haven't died yet, so how do they figure out what my frequency of death would be each year, right? So other than I haven't died yet, that's all they know. Well, they cast a wide net, a large number of more heterogeneous people, and they interpolate, and that's what we try to do with projects.
Yes, I think we need more sort of randomized trials of A versus B project methodology. But I did actually come across a conundrum for this one, Doug, and I've mentioned it a few times when it was on a commission. I had to bring many different project life cycles together to have one enterprise framework, and that the existing frameworks all had a different number of gates. And the question I was asked is, what's the optimal number of gates? And I could not find an answer to that question. There was no evidence for it. So in the end, we had to do it through logic and reasoning to select a number of gates. And at the time, I would have loved to have done, let's have some of the organization doing it with this number of gates and others doing it with this number of gates, and then we had the evidence. And if we could have allocated them randomly just to the number of gates you would have had, you would perhaps have had an answer by now. That was about 10 years ago, but we didn't. There's no answer to that. And yet, there, we have it's all universally, don't we? We have methods and frameworks with a defined number of gates in the life cycle. Yet, how do we know?
Well, I do. I like to use these measurement maxims when we talk about methods of measurement, and they're just sort of guiding principles that may not always be true, but they're good assumptions to start with. One is you probably have more data than you think. Mm-hmm. And secondly, you might need less data than you think when you do the math. And finally, there's a good chance it's been measured before. So how much time do we really spend researching existing work in that field? Someone might have done a large clinical trial or something related to it that might even slightly inform our uncertainty about that particular problem. That's where I like to start. In these big uncertainties, the first thing I like to do is, and it's so easy to do now, I don't know why more people don't do this. When I started doing this kind of research 37 years ago, I would go to a library and make copies of microfiche and look up index cards and check out books. There's advantages to that, yes. But why don't we do things more often, like this basic research? Who's already looked into this problem? Yeah. It's so easy to do now. You just ask ChatGPT for some good references, and they might hallucinate a little bit, but that's pretty easy to confirm if they were. So just start with that. A little bit of Google search, a little bit of AI help, often people are surprised.
And those three things you just mentioned, I think, is in the sort of the opening few chapters of the book, and it was one of the things that did sort of stick out for me. Let me, if I can paraphrase it again, you need less data than you think. You probably have more data than you realise, and someone else has probably measured it before. I think that's three great mantras to live by when you're thinking about, okay, what is it I need to inform the decisions on my project, or for this part of my project, or this task on my project. So we haven't really talked we sort of dived into the topic rather than talking about the book. So tell us about the structure. It's in 3 parts, isn't it? So the formative part, which is what we've really been talking about now, which is about decision science and measuring. But can you just talk us through the three main sort of sections of the book?
Yeah, well, the first is exactly what you said. We describe the problem, and we propose also how to choose among methods. So by the time you get out to the 3rd chapter, we're talking about how do we know what works, given what we've talked about so far. Why don't we rely on case examples alone or experience alone? And, the problem of the analysis placebo and things like this. So we show that, repeated clinical trials are a great way of knowing what works. And of course, mathematical proofs. That's there are things where that applies. Several of the next chapters all deal with how we think people should do things like risk analysis, estimating cost and schedule, reference class forecasting, for example. We get into how we measure benefits and how we measure progress, right? On the risk analysis, and really all of them, we end up debunking some popular things as well as showing what some feasible alternatives are, things that actually show a measurable improvement. And we resort to research, not just within project management, but even just within decision psychology in general. People are systematically overconfident, highly inconsistent, influenced by irrelevant, random external factors. So is there a way that we can control for those in all decisions? And it certainly applies to project management decisions. So that's what the next several chapters are. And then the last few chapters are really a kind of a call to action. Let's summarize all of this and say, what should we do? How do we start at an individual organizational level? We talk about what we call the meta project. Just like your most important decision is how to make decisions, your most important project of all the projects in your portfolio is how to improve projects. That should be the #1 project in almost any portfolio, unless somebody believes they're already doing them optimally, right? That is probably the #1 project you should do. And then at the very end, we have a much more global, what we hope that project management does in general, and some bigger goals for project management. So that's chapter 12. We get into, I think, a little bit more vision, I suppose, in the very last chapter, and kind of wrap everything up. So that's how it's all structured.
Brilliant. So I like that idea of the most important project is the project to improve project management. So I guess the MPA, we're probably a meta association then. So I might have to think that through. My logic works on that. So yeah, I really like the structure of the book. The three sections, as I say, the first bit in terms of the foundations, if you like, in terms of the decision science. And it's interesting because the book title about how to measure anything, but we've been talking about decision making, through most of this discussion so far. The middle section, I took as sort of the application, sort of applying that to the world of projects, and it was interesting that you sort of took us through different aspects of project management, and the first section is about risk, and it was sort of, for me, it's one of the harder elements to, if we think about measurement, because I do recall listening to sort of Professor Eddie O'Beng once, where he says, whatever you put on your risk register in terms of probability or likelihood will be wrong by the end of the project, because at the end of the project, that risk has either occurred or not occurred. And in my own experience as well, in terms of the numbers that people put in, whether we do the nominal scales of high, medium, and low, the evidence of that risk occurring on similar projects doesn't really stack up with what people put on their risk registers. So I was really pleased that you tackled the issue of risk, which can often come across as a bit of a science in terms of how it's interpreted by the senior decision makers, but it seems that there's lots of opportunity for sort of flawed thinking and flawed analysis within there. So perhaps just give us your top tips then in terms of how to measure anything and improving our approach to uncertainty in risks.
I suppose I would start with challenging that previous statement by that
But the 0-1.
Yeah. So the way when we assign a probability and we say something's 20% likely, if a person is well calibrated, in other words, they're realistic about their uncertainties, that means if I observed a large number of judgments where they said something was 20% likely, it would have happened about 20% of the time.
Mm-hmm.
It's not wrong at the end unless it happens much more than 20% of the time or much less than 20% of the time. You can't tell by looking at one thing. The only time you know that something is wrong is when you had absolute certainty. You said something was 100% likely or 0% likely and the opposite occurred. Then I know that's wrong. Mm-hmm. Any other one, I have to look at relative frequencies. And then within that frequency, I have to compute a statistically allowable error because all the events I assign, let's say, a 5% likelihood to, that's a random sample of events. And as a random sample of events, I can be close to 5%. So that's what a well-calibrated probability really means. If I say that a coin flip is 50% likely to be heads, and then I flip it and it turns out to be heads, no, my 50% was correct. Because over a large number of trials, it would be heads 50% of the time, right? So yeah, first I would challenge that statement. I know that I've run into that before, by the way. I have almost scripted, practiced, challenges to those sorts of things. I should just make an app or an AI out of it and just say, here's objection number 47, and here's my response to it, because it's pretty scripted now. I think there's the things that we talk about, by the way. We don't object to the use of subjectivity per se. What we object to is the use of pseudo math and uncalibrated intuition. That's what some subjective methods measurably outperform other subjective methods. In other words, you can test the performance of subjective methods objectively. And it's been done quite a lot it's been done for decades. There's been research on this. So we don't really have to reinvent stuff, although we do have a lot of data of our own, but it's been researched to death. People start out drastically overconfident. We know this for a fact. And most people, our data shows about 85%, can be trained to be about as good as a bookie at putting odds on things in about half a day. That's what our data shows. At least when you're calibrating people, you find out who's not good at that. And you can kind of leave them out of the estimates, I suppose. But most people will be pretty good at it after proper training.
And to get back to your question, Andy, right? So, a risk is always difficult, because it's in the future and it's uncertain. And that's kind of exactly why we started with that. Let's start understanding how we can do better measurements. And as we said, right, measurements are always there to reduce uncertainty. So in most projects where we introduce uncertainty is through that idea of risk management and risk forecasting, and planning and risks. And it's probably still almost the most common standard on projects that you have some sort of deterministic estimates of cost and schedules, and then you have some sort of risk that you add on top of it, and suddenly sort of a point estimate turns into some sort of probabilistic thing, right? Which kind of, I think we would almost call that's kind of a pseudo probabilistic estimates, because, technically the build-up that we're doing, they should also be full of uncertainties that can all be quantified and put into a model to come up with a much richer, much more complex project. So that's why we kind of started there, because most people start thinking in ranges. Here's a couple of points where we are, budget, deadline, and then let's think about sort of ranges that come because some things might happen or might not happen, or there's some other uncertainties that we can already know something about. And so that's typically the point where we turn something from a single number to a range, at least, hopefully, in most projects. And so that's kind of is where we started, because that's probably where most people are considering these kind of uncertainties already, and then in the later chapters to actually go into, cost, schedule, but even progress is an uncertain measure, right? So exactly how far we're into this project today is not inaccurate number. It's probably a range. Today we might be between 78 and 82% complete. And at the same time, because we measure these things quite often, and as you said earlier, right, all measurements have value and all measurements cost money. And there's always that very big fundamental question, where does it really matter whether we measure more or spend more time measuring things or more time reporting things? Does it actually tie back to a different set of decisions, a different set of decision outcomes, and therefore has any value? Is there any value in all the stuff that we report all the time?
I think another thing to add, because you talked about, in your question, you mentioned that the subject of risk and how do we quantify risk and risk management often comes through as very scientific. And we actually looked into, what type of methods outperform others. So that was the big point of the book. And what we found was that there's a lot of, in project management, there's a lot of kind of methods dressed up as scientific where they aren't really in the first place. And so one of the things we found was often like the use of scores and scales to quantify, for instance, risk often adds uncertainty rather than reduces it. So you really shouldn't be using those types of methods. There's also like scores and scales, and that's often applied in different types of project management methods. Like for IT or software development projects, you might be using story points or t-shirt sizes to kind of quantify effort for tasks. And from what we can tell from the published research in our own survey and our own data, all of that stuff you really just shouldn't do. Just report the actual estimates of effort rather than using scores and scales, because they do just add uncertainty. The same with risk matrices. At best they don't do anything, but at worst they also add uncertainty in terms of both because inherently we're uncalibrated humans are pretty bad at adding probabilities to things, but also the way that they kind of quantify and add up together the risk matrices often really isn't helpful. You are better off doing at least some maths, even though it's easier to use these types of methods, which may be why they're so popular, right? Yeah.
Yeah, and we treat the scales as linear, don't we? And they may not be. So that when you plot, the probability times impact, you're mixing things that don't necessarily help you make better decisions, which I guess is the key point you're trying to make.
Yeah, and then you give it fuzzy labels, right? We looked at some research while we wrote the book, obviously, and there's some fascinating studies by psychologists that basically ask people to give words like probable or likely or very likely and assign a percentage figure to that. And when you say, for instance, something is likely to happen, people, once they have to turn that into a number, they got all sorts of answers, sort of most between sort of 50% and 90%. And we already talked about this, sort of that it's hard to be consistent, and inconsistency creates, another set of noise and uncertainty in our decision making. If you now sit in front and have a discussion in the room, are we likely to hit the end date? And one person in the room thinks, oh, that must mean we must be 90% likely to make that. Another one says, 50-50, that's okay for me to be likely. You don't have the same conversation, you don't take the same action, you don't make the same decision.
Yeah, I once sat in on a sales meeting. It was a bid for it's probably about £1 billion worth of work, and the sales director said there's 3 potential providers of this, and they each have a 50-50 chance of winning. Like, I don't think that works. I think what he meant was they had an equal chance of winning, which is not 50-50. But he was trying to convey to his board that there's a 50-50 chance that they would win, but there were 2 other bidders. And he said they're all equal. So even that is just sort of showing how we can sort of use language that doesn't really reflect the maths in play. So the middle part of the book, you tackle, you say, Alex, sort of risk and cost estimating, scheduling, progress. I really like the progress bit as well, because intuitively, as I was coming into that section, I just thought, well, work done is work done. Where's the the uncertainty, that coming back to the original definition of the reduction of uncertainty. But tell us about the insights that you sort of gained when you were looking at applying the sort of decision science to progress.
I think there was some really interesting sort of things that we uncovered, right? So in terms of a lot of these things is we looked at their different progress measures, like you might see in different projects. I do remember my very first ever project I worked on was in an IT project in banking, and somehow or other they measured it in a way where they simply asked people how much have you done, right? So how complete are you? What's your current estimate of that? And then they aggregated that up, and of course it didn't work, right? The project was way too much, over-reporting of completion. The typical, the first 90% of the project take 10% of the time, right? And then sort of listen where, and that was the first time a long time ago when we started to think about is how can we measure that better? Sort of is looking into what is the estimated work that still needs to be done, and sort of versus the work that has been done, and all sorts of other interesting measures. And then there's of course earned value management, which we also, interestingly, as Andreas said earlier, in our survey that we did for the book, found no particular link to the outcomes of projects and use of earned value or not. And that's a very big element there. And then we also went around and asked, how do people measure progress on projects? So seemingly maybe not a trivial, but a very basic questions for projects that we measure that or report on that. And what really, I think the most interesting thing about this is was that the reflection that the answer depends on what kind of decision or what kind of question you actually want to answer with that question of how complete are we, what's our progress. So there's an element there where we want to know, sort of say, for instance, what's the work that has been done? How much money do we need to pay to our contractors and vendors and our subcontractors, right? That's what EVM originally was invented for. But then there's also questions around, can we are we going to hold the deadline? Or how predictable is the work that we are performing? So a lot of people, that kind of question, about time and project and progress is, really depends on what kind of question you ask. And to yours, right, should be easy to say is what is the job that has been done? What's the work that has been done? That most projects measure that once you have some good sort of bulk of work, some sort of volumetric thing that you can measure in square meters or rooms or sort of those kind of works, then people can tick that off and you can measure progress there. But say for instance, how likely are we therefore to hold the end date, or how good are we at estimating our schedule? Those are all questions where you would have to look at other elements or other aspects of progress on a project. So it depends a lot, so what do you really, why? I think that's the most important thing, not only what is progress and how do you measure it also, but why do you want to measure that? Yeah. But that depends upon, right? And I think we cite also some interesting thing where, can then be somewhat of a placebo. We went into a project that was apparently, project management office said we are totally brilliantly measuring that, big underground train station, and we measure this by the rooms that have been handed over from civils to electrical and mechanical next step, and sort of they had daily stats on how many rooms have been over and the velocity of doing that. And but what I completely ignored was that actually the whole project plan and the end date depended on one room that needed to be handed over, right? And that was in the basement, and that was the room that would house all the substation equipment to power on the whole thing. So the MEP guys or girls couldn't do anything until that room was handed over. Unfortunately, it wasn't the basement, they started at the top. So, it was great that they counted hundreds of rooms and how many had been handed over, while the whole project was just waiting on them to finish this one room,
There's a bit equivalent to doing like a 100-mile journey in your car and 90 miles of it on motorway, and and thinking you're going to do the last 10 miles on the A roads and B roads at the same speed as the motorway journey, isn't it? So, yeah.
I know. And you find out that you forgot the house number, and then you spend another 2 hours searching for the right one on the street, right?
So you also talk about the intangibles in that section, and I think you relate that to sort of benefits management, as we sort of discussed right at the beginning. So, so what's our approach to measuring intangibles? What's the top tips that we can share for that challenge?
Well, I suppose one thing we can do is ask you for the most difficult measurement you can think of for intangibles. And I'll just demonstrate exactly how we do it. What's the hardest one you ever heard of?
Oh, let's pop some of those in the chat for those who are listening. Let's pick 2 or 3 interesting ones from the chat. So I would sort of think about my sort of my sponsor confidence. How about that one? Can I, if I'm the project deliverer, can I measure my sponsor confidence?
Sponsor confidence, great.
Or investor confidence.
So
you want to do it that way.
What is that? Here's the first question. Design maturity, I like that one too. Start with, this is how all scientific inquiry starts. First, we have to define what we mean. I don't think I know for certain exactly what you mean when you said stakeholder confidence, right? Or investor confidence. So what is it you mean? And specifically, what do you see when you see more or better confidence? What is it that you see?
Okay, so if I've got more confidence, I guess they'll be potentially more engaged with what we're doing.
Engage with what you're doing. So,
yeah.
So in other words, if I were to make a series of observations, there might be a number of engagements over a period of time, possibly. Now, I'm sure there's many other things it could mean, but that's one of them, right? That tells you something all by itself, just number of engagements, right? Now, there might be several other things. I could ask them, and what if they said, I'm very confident in the outcomes versus I've lost a lot of confidence in the outcomes? Is that completely uninformative? No. I would have to update my estimates based on that. So one of the reasons why things like that might seem intangible is they're really umbrella terms that stand for lots of different observable things that have to be unpacked. There might be 11 or 12 other things that means to you. We just have to unpack them. The last question here is, why do you care? What behaviors are you expecting? What outcomes are you expecting as a result of your observations? So why would you care about tracking that? In other words, what thing would you do differently if confidence were surprisingly high or surprisingly low? Is there any benefit at all for knowing more about it?
Yeah, so I would want to know in terms of continued investment in terms of potentially resources or funding, or whether that could be a slice of their time so that I can get better decisions,
Right.
quicker decisions from them. So that would be why I'll be interested in the level of engagement or the confidence that the sponsor or investors have.
Well, certainly, if you're managing a project, and all project management comes down to intervention decisions. It's all intervention decisions, some that you've anticipated in advance and some that are kind of ad hoc, okay? But the reason why you're interested in confidence is that you might decide to do something differently. There might be some intervention or some change in strategy if you found out that investor confidence was low or below some amount. And what I mean by investor confidence being low is engagements have fallen below this. They said these things to me, it's taking longer to get approvals for certain things. Maybe that's another one. I'm just winging it.
Well, they reduced the runway.
But all of those observable things are helping you forecast something about their future behavior. If you thought that, say, investments might be cut, suppose you said, oh, based on what I'm finding out now, I'm thinking there's like a 60% chance of investments being cut. Would I do something differently right now? So once you decide what something means, frame it in terms of why you care and what you see when you see more of it. so that you're actually making a forecast based on your observations. Then it all becomes measurable. The only reason it didn't seem measurable is because we didn't really know what we were talking about or why we were interested in the first place. As soon as we figure those things out, it's all measurable. There's no such thing as something you care about that doesn't have tangible, detectable consequences.
And then to link that further forward, right, we always say, measurements are only valuable if they inform a decision, otherwise they're just noise. And and therefore, sort of the next step then would be to actually start thinking about what is the threshold I should set. Say, for instance, I've got a project board, and one of the stakeholders now for the third week in a row has sent a deputy, or even just sent apologies, right? Is that a decision threshold when I will then mobilize resources to invest and maintain or rebuild that relationship with that particular stakeholder? Sort of that then becomes suddenly from something very nebulous to something actually, we now understand what it is. Here's a proxy or tracer or something how we observe this, and then here we've got a threshold, and that will trigger something. That will trigger an action. So we're actually making a conscious decision about that.
Yeah, brilliant.
I like these other two.
Yeah, let's go for it.
Oh, yeah. So
design
maturity and risk appetite. These are great examples of it's been measured before. So risk appetite, there's a whole area of mathematics about specifically that. So how we measure risk appetite, one way to do it is to ask people what bets are acceptable. So I could ask decision makers, would you accept a bet where the benefits were 40 million pounds and the losses, the potential losses, if it wasn't successful, are minus 20 million? What's the probability you would accept for the loss? If it were a 10% chance of losing 20 million and a 90% chance of making 40 million, is that an acceptable bet? Now, there's nothing wrong with saying yes or no. Both of those are just representations of your risk aversion. This has been measured, by the way, a risk aversion by asking people a series of bets that are just barely acceptable. And here's the really fascinating thing we find out when we apply measured risk appetite to projects. Most decision makers would not have accepted most of the projects they ever invested in. That's fascinating. And that kind of leads us to a key, big picture point that we make later on, bringing it all together, call to action. One of the call to actions is fewer projects, bigger wins. These projects with kind of marginal benefits for a risk-averse decision maker, which most of them are relatively risk-averse, that's not nearly good enough. You should be looking for projects with much bigger wins. This actually gets into another point we make about something that Bent had made a point about, thinking slow, acting fast. And we've converted that into, well, there's a benefit in spending more time in planning and thinking through solutions. We converge too quickly on the type of solution that we're looking for. Decision makers often want to see us start coding or pouring concrete. And really what we need to start thinking through is a lot more solutions before we pick the best one. We converge too quickly. There's math for that too, by the way. It's called exploration exploitation. Or if you want, there's a metaphor called the multi-armed bandit metaphor in exactly that problem. So there's math for all of this stuff. It's been measured before is a great mantra for each of these. Design maturity is another one. What do you see when you see more design maturity? Is there something about a design that tells you it's more mature than another design? And what are the consequences of design maturity that would cause you to act differently? What are the decisions it would inform? Is there a threshold? I'm sure design maturity means several things. It probably means several different things. All of them are observable, that if we put them into and you can do this, either a formula or make a judgment from a calibrated person about the likelihood of various outcomes. And remember, all decisions are all based on forecast. All decisions have always been based on forecast. You're deciding that if I do X, these things will happen. And if I don't do X, these other things will happen. They're always about forecasts. So you're always forecasting outcomes. That's what decision makers do. That's what project managers do. Throughout the project, they're making a series of what we call intervention options. Unfortunately, they're usually winging it. Now, we're not saying that you can anticipate every possible decision you might need to make during a project, but there's a lot of categories of decisions you should probably plan for in advance that people aren't doing right now, including the option to cancel a project. That should be a deliberate intervention decision modeled in advance. It could even be part of a contract based on how you're actually measuring outcomes.
There's another element to kind of the quantification of intangibles, both that the kind of the umbrella term, I think, is really applicable, but there's also an element around these things can be hard to monetize. And so oftentimes intangibles are things you don't quite know how to fit into your model, or you don't know how to value, right? So that could be things like biodiversity. It could be things like reducing the risk of death. But one thing we argue for is that these things you really always should be monetizing, because that way you can account for them in your models. And if you aren't, that just means that you're basically assigning them a value of 0. And there's multiple methods you can use to kind of quantify or monetize, add value to these types of intangible things. One thing that you might be familiar with is like big transport projects are typically the main driver in that benefits case is oftentimes, time saved. How much time are commuters saving by us building this metro system compared to not having it? Time is not directly kind of monetizable, but you can look at it in many different ways. And typically the way that we look at it is through kind of stated preferences. So how much are people saying that they're willing to pay to save time, and revealed preferences. So how much are they paying to save time? A good example there could be like something, if you want to value, like how much is it worth us having the Grand Canyon in the US? One way to quantify like how much are people could just be to look into, well, how far are people traveling to the Grand Canyon? How much are they paying to go there? You can then quantify and multiply up that cost that they're willing to pay to see the Grand Canyon, and then look at the number of visitors, and that'll be at least one estimate of the value of having the Grand Canyon in terms of tourism, right? So there's many ways of doing it. I'm working a lot on biodiversity at the moment, and that suffers both from being umbrella term. There's lots of different understandings of biodiversity. It can be the amount of species, the species richness. It can be, how many species are at risk of extinction. It can be some kind of proportion. So how many butterflies do we have compared to bees, or like a lot of different things. And there you can also go in and look at preferences. And typically that's the way this is done. So which of these aspects of biodiversity do we actually have preferences for? And then you start measuring, the public is really keen on like not having species go extinct. So that'll be one of the primary measures. They also like species richness, having multiple species. So that'll be another element. And then those things can be difficult both to monetize, but they can also be difficult to estimate, right? Typically it takes biologists and geologists to go out in the field for months to count species in an area. But even in a topic like biodiversity, which is really hot for projects, there's lots of data already existing on all these metrics. If you just go out there, just from other fields like biology or ecology. So you can find actually good statistics and good data. You don't need to do that kind of assessments yourself and count the species yourself.
That's a great point, Andreas, about that sort of preferences, because applying it to transport projects, and I know that I suspect many people on the webinar are familiar with sort of web tag and how we assess them in the UK, but the preferences could be expressed in terms of things like connectivity, or your preference for taking low carbon transport, or your preference for reliability rather than journey time. And the way that we monetize our transport projects tends to be on journey time savings of economic travelers, and then that excludes all of the people that might be, say, someone that's doing care, that provides a real value to society, but they wouldn't be classed as an economic traveler.
I think that's a really good point, because I think oftentimes benefits doesn't get the attention that cost to schedule does in big projects, because that's what they're measured on. It's easy to see cost and schedule as the project is completed, but oftentimes, like in the UK, you also see the business cases for transport infrastructure will be both the time saving, but there'll also be a property price increase. But the only reason that there's properties are increasing in value is because you're saving time now going from this property into city center or wherever. So you're actually counting the same benefit twice, and then you're excluding a whole bunch of other things, like those you just measured or you mentioned, but also things like, if we build this road, we're going to see less congestion on other roads. Or we might see, if you build a metro, you're going to remove some of the cars from the roads, right, into the metro. And so there'll be a benefit there on a secondary market, kind of in economics terms. But there'll also be like air pollution effects or environmental effects. There'll be a whole bunch of other things. And that's definitely one area where there could be more analysis done to think about what externalities should we be including in our benefits analysis.
Yeah. I think this is really insightful, because those preferences and measures then influence the narrative for a project. So I'm sure HS2 would have been an easier sell if people along the route, had the preference of air quality and noise, for example, expressed as a benefit, because that's a benefit that people along the route are going to get compared to all of the wagons and traffic that would otherwise use the roads. I'm very aware of the time. So the third section of the book is the call to action. So what is the call to action? So other than debunking some of the myths that we currently operate on, but what's our call to action?
Well, I think the main one is the meta project. Everyone should start it within their organization, and then another component of the meta project is, why don't we see an improvement in projects after this enormous increase in certifications since the 90s? We don't see any change over decade in terms of cost overruns and schedule overruns or benefits being realized, et cetera. It seems very consistent. And so all of the new software tools, all of the certifications aren't helping, but the certification itself or the software itself is not a solution. It's what they're automating and what they're teaching. Those are what matter. And we still see too many things we were just at the Project Controls Expo. Andreas and I were walking around the vendor pavilion, and I noted that, wow, all the software that we're seeing with all the risk matrices and colors and the pseudo math, that's the same ones I saw a couple of years ago. Until they start changing, and until certifications and standards start including some things that actually measurably outperform other things, certifications are not going to improve. It matters what we teach and what we automate.
And that goes back to the point about best practice, because a lot of the time you just see that these are standard setting bodies or interest organizations. They'll say these are all different methods that we've used to quantify projects before, we've used to measure projects before. They don't really select, or they don't really have any opinions about which of these methods should you really be using. So that's one of our calls to action is, there should be more of a kind of critical view and an opinion about what methods should we be recommending projects to do, rather than just recommending to use the same stuff as we've always used, because not all of it works, right?
And how many gates to have in your cycle?
Yeah.
Exactly. And that's kind of, again, that's the common theme, right? We say we make better projects by making better decisions, and we make better decisions if we inform them with evidence and with data. So measurements, so in the same way, right, is now a great call for action, and that is not only for project decisions, but everything around projects and how we do this is this whole thing about measure what matters, quantify the uncertainties, and then make better decisions based on evidence.
Yeah, great. So, listeners, we've had our call to action. If you would like to respond, or has anyone got a question for the three authors? a chance to either put a hand up or to pop a question into the chat window.
Oh, you know, one thing we didn't mention quite yet was the measurement inversion. We didn't talk about that one.
Oh, yes,
but,
yes.
Yeah, that's a really important finding. We've been computing the value of information. There's formulas for this. It's been done. We didn't have to invent it. It's been part of decision theory and game theory really since World War II. But more or less, the simplest explanation, it's the cost of being wrong times the chance of being wrong. There's more elaborate things to take into account. You can be wrong by a little bit or wrong by a lot, but you can compute the value of information for every uncertain variable in a decision. And we've been modeling this for, the past 27 years here at Hubbard Decision Research, and it's been done before. But when you compute the value of information on every uncertain variable in a decision model, and there might be a dozen, there might be 200 variables, we tend to find that the high information value variables are not what the client would have measured before. We call this the measurement inversion. There tends to be more effort spent on low information value variables, things that are less likely to inform and improve a decision, than the things that are the most likely to improve decisions. People are measuring all the wrong stuff. So the things that you probably need to measure are the things you probably haven't been measuring before. That's another item.
And that ties back to what we talked about benefits. For most benefits, for most decisions and projects, the benefits are way more important in determining a decision than, for instance, the cost or the schedule. But we're spending most time, most models we have for projects drive us to reduce the uncertainty around cost, but less so around the benefits. And so that's where we see, for instance, one of those measurement inversions taking place, and I think to Nicolas' question of the unmeasurable, design maturity, we do a lot of the things in projects, particularly engineering projects, where we go to more detailed design in order to reduce the uncertainty and cost. And that's the main question. But then we also see that there's not a particularly high valuable measurement. So when we say we wanted to improve the design maturity, then most projects actually would be to in order to measure of what's the likelihood of us capturing the benefits or realizing the benefits we want to deliver with a project, and that will give you a very different measure of design maturity than the classic one where you go and measure how much detailed design has been done to inform a cost build-up model.
Mm-hmm. Yeah, that's a reflects in reporting as well, isn't it? In terms of the time, the real estate, if you like, on a reporting pack of things that are, I guess, low value in that inversion map to those that are high value. We have another question from Timothy. Do you see a link between simplicity and impact in measures?
I think the first clarification question I'd ask Timothy is, do you mean the impact of the measure or the impact of the project? The simplicity and impact of the measurement, or you're talking about the simplicity of a project and the impact of a project? As in, simpler projects have a bigger impact. Is that what you mean?
Or is it simpler measures have more impactful decisions?
Impact of the measurement on delivery. Oh, yeah. Okay, absolutely. Delivery comes down to the series of decisions by a project manager, certainly a series of intervention decisions. And those intervention decisions should be based on measurement. So at a very fundamental level, I would say yes.
And also, the simpler the measure, the lower the cost of measuring. So one of the things that Doug just mentioned in the book, we also discussed this, is that you can calculate something which is the economic value of perfect information. So to a decision maker, what would be the value if you had zero uncertainty? If you can do all the experiments and observations in the world, with infinite resources, and you can reduce it to zero. What is that as a value to the decision maker? And then the rule of thumb is roughly you should spend 10 to maybe 20% of that value on measuring a thing. So it's kind of a question here, is more uncertain decisions with greater ranges of uncertainty, they typically suggest that you can spend more money, or you should spend more money on reducing them, and you can translate that into sort of your own little cost-benefit ratio for measurement. And but also simple measures are cheap and can reduce the uncertainty, maybe not perfectly, maybe just a little bit, but that might have a very different, that has value in its own right. And the one thing sort of is, and I think we lay it out in there, it's not sort of just a linear sort of process, but more of a circular one, sort of is an understand where your current uncertainties are, prioritize them, and sort of where is the greatest value of reducing them, and then do something about it, and then reprioritize them again. So in the beginning, you might have a simple measure to take some of the uncertainty out, and that might be just very good enough for that particular decision.
Just to add to this, that there's also a danger of simplification. So things like project health scores, which is actually just consolidated information about a whole series of things. That can be metrics in terms of progress, it could be in terms of cost, in terms of some kind of how good have you been at modeling the risk. And sometimes those are condensed into a score. So you might take all those types of metrics and then average them out to this is an 8, this project, in terms of its health. That kind of simplification often just adds uncertainty, and implicitly it means that we're adding we might have preferences about some of these metrics. We might actually have preferences of delivering on time rather than delivering to cost. And so if you just average out, that kind of preference goes away. And so the simplification of the metrics can be problematic in terms of basing decisions on those. And there our recommendation would just be just actually use the metrics. So if this is to create information for decision makers or the board, in my opinion, they would like to see, well, how are we doing on cost and on time and on progress and all these things, rather than this is an 8 in terms of its health.
Yeah.
That's similar to the
don't make it simpler than it should be, right? So keep it simple, but not too simple.
Yeah, great. We've got
I have responses to both of these quotes.
Okay, go for it.
And I've written about both of them extensively, actually. Yes, decomposition helps. I talk about the Fermi decomposition. We talk about it in the book. The Fermi decomposition is very helpful, but it matters what the math is that you do with it. When Fermi was doing this, he was doing the proper algebra. Was really arithmetic with estimating the number of piano tuners in Chicago. What's the population of Chicago? What's the average size of a household? So how many households are in Chicago? What percentage of households have pianos? How often does a piano have to be tuned? Or how many pianos can a piano tuner tune given travel time between pianos? And they come up with a range, an estimate, but they're doing the math with real quantities, not pseudo scores and things like this. The problem is when people are just listing risk in a risk register, they're not even independent risk, and some of them aren't even risk, and then they're putting this score stuff on it. Yeah, you can decompose with that all you want, you're not going to get better. Yeah, you got to do the math right first. And there's math for risk, absolutely. For pre-mortem, so that's Gary Klein's term, the pre-mortem, right? So yes, it's a way to think about what could be wrong. You start with the assumption, this is a fascinating way of thinking about things. You start with the assumption that it's a year or two after the project is supposed to be done, and it turns out it was a massive failure. You just assume that. Then you explain what went wrong. Apparently, this kind of prompts people to think differently, because Gary Klein was having a hard time getting project managers to imagine what might go wrong with their projects. So he reversed the framing here and said, imagine it's 5 years from now and the project was a massive failure. Explain what went wrong. Apparently, people are better at explaining past things than predicting future things, and everyone's always got explanations for what went wrong historically. So you see this all the time on the news. Pundits talk about what went wrong historically, but they couldn't have made forecasts to begin with. So it just engages a different part of our brain. We pretend that we've got 20/20 hindsight, and it just turns out that yes, it is effective to get people to think about things that could go wrong. But then do the math right. Don't just put them in a risk register or a risk matrix with high, medium, low and stuff, red, yellow, green. You got to do the math right. Otherwise, decomposition doesn't help at all.
Yeah, one of my pet peeves on risk registers is things like, there's a risk that the supply will be late, and then sort of a random likelihood on it. And then when you really probe in terms of, well, how many times has this supply been late before? And I go, well, they've never been late. Okay, well, why is it on the risk register? And they end up being sort of bothered by something that's never happened before. Okay, it's nice to be prepared, but do you see what I mean? It's not a 20% likelihood, which is something that can often be attributed to those rare events.
You know what? We even talk about the probability of events that have never happened before. There's math for that too. It's called Laplace's rule of succession. It's the mean of something called the beta distribution, but the mean of that distribution is just simple arithmetic. We just show people how to do it. You just say, here's how you compute the probability, assuming that your only data is your own personal observations in this field. Mm-hmm. Right? Now, you probably have more data than that, but you can start with the idea that, well, it hasn't happened before, and Laplace's rule of succession will give me a non-zero probability that it's going to happen next time.
It is pretty low.
So if you've had 8 projects, and they were all the deliveries were on time on these 8 projects, what's the chance of a delivery being late that affects the schedule on the next project? Well, that's 10%, according to Laplace's rule of succession. If that's all the information you had, you probably have other information, but that's a very good first cut way of looking at the probability. The next one being wrong.
Great. Well, sadly, we're out of time. I could carry on chatting on this topic for another hour, I think, because I've learnt a lot. I learnt a lot from reading the book, so I would recommend people to find a good place to. I'm assuming it's on Amazon and other rubbish booksellers as well.
Available at all good bookstores, as we say, right?
All good bookstores,
yes.
Yeah. So, last thoughts. I'll give you each a chance to sort of gift us another pearl of wisdom each before I call time on our webinar today. So, Andreas, I'll let you go first.
So we talked about so many things. I think. So why do I think that you should buy the book? So I think the book is kind of it's kind of a novel approach to project management, actually bringing that kind of economic theory and decision theory to problems in projects that haven't been solved so far, and that there's just so much actual data and evidence out there which we've tried to collate. So I think. For me, it's been a really good exercise of actually looking outside of the project management field, where a lot of the problems are the same as you see in project management. They're just not framed as project management. And so I think one thing in my experience as the head of data science at Oxford Global Projects is that there's just so many assumptions around the limitations of the data that's out there, the quality issues with data that's out there. We can't really capture data, and we can't even capture our own data. But a lot of that stuff is there's more data, and it's a lot easier than you think to actually utilize it in a good way. I think that's my biggest learning from this.
Great. Thank you, Andreas. So, Doug, you've got 20 seconds now. So.
Oh, yeah. Well, I can tell you my biggest learning is the research that Alex did on how big a component projects are of the world's GDP. And how problematic projects have been, and how it hasn't gotten better. If we keep doing the same thing over and over again, it's not going to get better. So we try to look for different solutions, things that people aren't doing right now. And I think we're talking about a lot of things that people are not doing right now. So this might be really one of the most important things I could write about. What if we were able to improve projects by 2%? That would be an enormous boom. That would be a massive benefit. I think the best way to spend 1% of a project portfolio is to figure out how to improve the other 99%. That's your meta project right there.
Love that. Thank you, Doug. So, Alex, you've now got 10 seconds.
Okay, great, right. If you want to do better projects, we need to make better decisions. And in order to make better decisions, we need better measurements. And that's why you should read the book.
Love it. So, yeah, it sort of chimes with my view that all projects are experiments. And if we think of them experiments, because there must be experiments, otherwise we'd know how to do them every time, wouldn't we? But and reminding myself of what I learned in school, if you do an experiment, you need to have observations and measures. So yeah, I'm all for it. So thank you for your time today to firstly taking time out to write the book, but then sharing it with us on this webinar. And thanks to all the people that have joined us for this lunchtime. So hope to see you all again sometime soon. Thank you.
Thank you very much.
Thank you for having us.
Thanks.